Scientists trigger earthquakes in the Alps to predict future events. Scientists trigger earthquakes in the Alps to predict future events. Researchers are deliberately triggering earthquakes deep within the Alps, not as a destructive act, but as a novel approach to understanding earthquake behavior and improving predictions. The Fault Activation and Earthquake Rupture FEAR project aims to pinpoint the warning signs nature provides before a quake strikes, a critical goal in seismology given the limitations in our current understanding of earthquake triggers. The challenge of earthquake prediction, despite advancements in global fault line monitoring, scientists remain puzzled by the immediate triggers of earthquakes. A key question is why some ruptures are confined to short segments of fault lines, while others extend for miles, leading to more severe destruction. Currently, geoscientists can only analyze events after they occur, leaving a significant gap in our ability to anticipate and mitigate risk. As Domenico Giardini, professor of seismology and geodynamics at ETH Zurich, explains, what are the signs that nature is telling us? Invariably, they become clear after the quake, not before, so we are trying to understand much better how to see the signs. Leveraging the power of the Alps to address this challenge, the FEAR project is leveraging the unique geological conditions of the Alps. Situated on the border of Switzerland and Italy, these towering mountains possess a network of deep-seated cracks, a legacy of millions of years of tectonic activity. The immense compression from the mountains above generates fractures within the rocks, occurring 0.6 to 1.2 miles, 1 to 2 kilometers below the surface. These faults naturally experience occasional, small slips, producing minor earthquakes. Taking advantage of a pre-existing tunnel originally constructed for a railway project, the FEAR project is conducting experiments by injecting water into the fault to control the timing of earthquakes. They would have taken place sooner or later in the history of the Alps, but we make sure they happen next week, notes Giardini. A controlled experiment, the process mirrors what occurs when oil and gas companies inject wastewater into faulted regions, like Oklahoma and Texas. This practice reduces friction, facilitating fault rupture. However, the FEAR project distinguishes itself through its deployment of a dense network of seismometers and accelerometers right on the fault itself. This allows researchers to precisely measure how the fault moves in response to the decreased friction, a level of detail not achievable in natural settings. The team has already successfully triggered hundreds of thousands of quakes, ranging up to magnitude 0. Earthquake magnitudes are measured on a logarithmic scale, allowing for the existence of very small quakes with 0 or even negative magnitudes. Future research. Temperature and magnitude. Next week, researchers will introduce hot water into the fault to assess the impact of temperature on earthquake development. In March, the project plans to trigger quakes up to magnitude 1. The ultimate goal is to establish a predictable link between specific parameters and earthquake size. If researchers can successfully trigger quakes of desired magnitudes, they will eventually be able to assess real-world faults, calculate the necessary stresses to produce quakes of various sizes, and hopefully improve predictions. Implications for earthquake risk assessment. Giardini points to the devastating February 2023 earthquake in Syria and Turkey as an example of the potential benefit of this research. We know that fault will continue toward the south and toward the north. We want to try to understand, is the next quake going to be a 7 or an 8 or 8.5? Early findings suggest that factors like strain within the rocks surrounding the fault are critical indicators. Researchers are also gaining insights into how earthquakes propagate from one fault to another. We are seeing examples that we produce ourselves underground that look very much like what happens in nature, Giardini concludes. The FEAR project's innovative approach offers hope for a future where earthquakes are not entirely unpredictable, and communities can better prepare for these inevitable natural events.